Hey gang, in this video I want to talk about comparing distributions. So I've got some Milwaukee Brewers data here with their ages and their weights, and on this Desmos page that I've already created, we have the age breakdowns of Green Bay Packers players. So what I'm going to do is I'm going to, on Desmos here, I'm going to bring in a box plot. And then I'm going to highlight all of the Milwaukee Brewers players' ages. Copy those, Control C. Go back to Desmos and Control V, paste those in. Go back, push the home key to get back to the front here, put my parentheses in front, go to end, and put my parentheses at the end to get my box plot. We're not going to see that just yet. We'll come back to it in a second. First, I want to make the histogram as well. So histogram, Control V to paste my data in, and then go back to the front, put my parentheses in, go back to the end, put my parentheses. We'll do comma 1. That bin width tells it to do each of the values or the bins will be a width of 1. If we wanted to lump years together, we'd change that bin width to be 2 or 3 or higher. We're going to stick with 1 here. 1 will work pretty well. Close that, and just like we did with the Packers players, we're going to make this a relative frequency histogram. And what's cool here now is that we can actually compare the two distributions. We can see that this purplish one, which actually I'm going to change that color to green because those are Packers. The green distribution is for Packers, the blue distribution is for Brewers players. And we can see that it looks like the middle of the Packers distribution is over here to the left, whereas the middle of the Brewers distribution is more in the middle here. And the Brewers distribution also looks a little bit more symmetric. Okay, whereas the Packers distribution, we kind of skewed to the right, tailed off to the right. So, just by looking at this distribution, we might be able to say that it appears that Brewers players on average are a little bit older than Packers players. Okay? For the box plot, if we want to keep the same x-axis, 20 to 40, but now if I go from 0 to 2, we see the box plots, but they're on top of each other. And that's not very easy to see. So I'm going to change this to go from 0 to 4. And what I'm going to do is I'm going to come over here to my box plot. Actually, first I'm going to change the colors on this as well to make this one green and this one blue. And on this Brewers box plot, I'm going to keep the height at 1. I like that. But offset, I'm going to make it 3. Okay? Or I could make it 2, and then it'll be right on top of this other one. And so what this does is, again, it lets us see and compare these two distributions. For example, we can see that the median Brewers age is higher than the third quartile for the Packers age. Okay, so that means that when you take half of the Brewers players, that amount, that age value that splits it in half, is higher than the top 25% only of Packers players. Okay? We can also see that the breakdown from bottom 25% to the top 25% in age for the Brewers, that value is higher than the median for Packers players. Okay? So we can see here again with these two box plots, one on top of the other, how the distributions between the players' ages for Milwaukee Brewers players and Green Bay Packers players, how they're really compared to one another. Okay? Now, something else that we can do is we can, if these appear to be symmetric, we can turn them into normal distributions. The Green Bay Packers one seems like it's not quite symmetric. It's got some skew to it. We may not want to use a normal distribution for the Green Bay Packers data. But the Milwaukee Brewers data looks pretty symmetric, and a normal distribution may fit that pretty well. So in another video here, we're going to take a look at putting a normal distribution to this and seeing how well that fits our data and how we can use that to talk about percentiles and other things around our data set.